Hello friend, today we will discuss about the electric discharge machining process. This is a part of the thermal electric machining process. Earlier we have discussed about the mechanical process. But today we will discuss about the electric thermal machining process. Means what? We are using electrical energy to generate the temperature. Temperature means what? Thermal. So thermal and electrical energy is combined to remove the material. Sometimes it is also referred as spark machining because very high energy spark is generated between the tool and workpiece. Spark eroding because the material removed by the erosion, burning, die sinking, and wire erosion. These are the different name of the electrical discharge machining process. It is manufacturing process where a desired shape is opted using electric discharge, means spark. Here what we are doing, we are using the same shape which is required on the workpiece. Like in ultrasonic machining, initially we have to generate the shape which is the required, then we have to use that shape into the tool again that is used to generate the high amount of spark. This spark will erode the material and ultimately we will get the final shape. Material is removed from the workpiece by a series of rapid recurring current discharge between two electrodes separated by the dielectric liquids and subjected to electric voltage. Next we will discuss what is a dielectric liquid. But what we are doing, we are separating positive and negative polarities by the liquid. It may be the kerosene or you can use different material. But in that case we have to use the high voltage. One of the electrode is tool. Basically we are keeping tool as the negative iron and workpiece as a positive. Tool electrode or tool or electrode, you can call it anything. Other electrode is workpiece, that is the positive. Here we are keeping tool as a negative and workpiece as a positive. As the distance between the two electrode is reduced, the current intensity becomes greater than the strength of the dielectric, causing it to the break. What we are doing, we are initially what we have done, we have separated both the electrode positive and negative, and it is filled with some dielectric fluid. Now what we are doing, we are reducing the distance between the electrode. Due to the high current intensity, what will happen? The spark will generate, and the spark will melt the material, basically erode the material of the workpiece. This is a basic concept which is used to remove material from the workpiece. Now we will discuss some history how this technology was developed. This allows current to flow between the two electrodes. This phenomena is the same as the breakdown of the capacitor. In a normal capacitor we have in our home, that is in the fan or tube light. Initially we are using only as a starter. Basically, what is the function of the capacitor? It will store the power and initially, and it will break. As a result, material is removed from both the electrode. Once the current flow stops, new dielectric liquid is usually converted into the electrode zone with the help of the pump. Actually, what we are doing, we are continuously supplying dielectric fluid between both the electron. So what will happen once the material is eroded, or once material is removed, new fresh dielectric fluid is filled. Adding a new dielectric liquid in the electrode volume is commonly referred to as a flushing. As we have discussed, it is supplied by the pump. Also, after current flow, a difference or potential between the two electrodes is restored to what it was before breakdown, so that new dielectric liquid breakdown can occur. Ultimately, we are replacing the fresh dielectric liquid to generate the breakdown. It was developed in 1770. The name of the scientist is Josephs. Initially he was studying different thing, and he got this machining process, erosive effect of the electrical discharge. Then further it was developed by the different scientists. In 1972, some was used electric discharge machining with the help of CNC axis that was manufactured in Japan. Actually, if you observe all the machining process, in all that we are using CNC controller. CNC controller is common for controlling the axis in XYZ direction. Only replacement is head. You can use abrasive water jet head, you can use abrasive jet head, ultrasonic machining, and today we are discussing about the electric discharge machining. So the CNC is common. Now, what are the general aspect of EDM? Electric discharge machining is primarily used for the hard metal, or those that would be very difficult to machine with the traditional technique. Same way we have discussed in the ultrasonic machining, but the condition is that the material should be conductive. Non-conductive material cannot be machined with the help of EDM. So this is a disadvantage of the EDM, we can say. Otherwise you can machine. In some case you can use insulating to the machining of the ceramic. EDM can cut intricate contours or cavity. You can cut any complicated cavity in hardened steel without need of the heat treatment to soft or reharden it. This method can be used with any other metal or metal alloys such as titanium, hastelloy, covar, and inconel. It is also applicable for this process to shape the polycrystalline diamond tools. This is schematic diagram of the EDM. You can see in this diagram we have two different parts. One is the electrical part and second is the controller. Basically it's a servo controller which is used to control the movement of the electrode. Here we have a tool in red color, that is the negative anode, and workpiece is kept as a positive, that is cathode. This is filled by the dielectric fluid, you can see in the blue color, and whole setup is covered with the casing. So in this process we want high amount of the current, not or in some cases people are studying the different parameter. We will discuss later on what is the effect of the different parameter on machine condition or final quality. Here we are supplying the current, that you can see that positive to the workpiece, positive is connected with the workpiece and negative is connected with the electrode. Here we have a tool as a cathode and workpiece as a anode. So what will happen when we are supplying the high amount of the voltage? Then we are reducing, we are gradually reducing the distance between the two electrode, or we can say tool and workpiece. So here tool is negative and workpiece is positive. Now electrode will try to move from negative to positive. So what will happen? Due to high amount of voltage, one layer is generated between the two electrodes. That is for the static, we can say for this small time. Then it will break. So when it break, it will generate the spark. Now spark having a very high amount of temperature, you can say from 8000 degrees centigrade to 12,000 degrees centigrade. So that is the main principle. The spark is used to melt the material. So gradually it will melt the material. So suppose your tool is square, so you will get the square hole. If your tool is circular, you will get the circular hole. So this is the main principle that is used in the development of the electric discharge machine. Thank you.